Now, on your timetables, there is for every single day a section called Times or Divide Reasoning. This one here, which I've highlighted. And there's one of those for every single day. When I was in school with two very hard-working Year 6s on Wednesday, this was one of the questions they asked. What is the Times and Divide Reasoning? Where is it in my packs? And what do I do? So I thought that perhaps I needed to make it a bit more clear about what it actually is. So, in your packs you have a set of activities that look like this, and they have the IC Maths logo at the top right. We've also numbered all of yours. There's no numbers on mine because this is the original, but yours is numbered for each day. So on day 1 you've got number 1, day 2, which is this one here, you've got number 2 at the top, and so on. So these questions are designed so that it requires you to think a little bit and to experiment with lots of different numbers. Quite often in maths we think of the answer, or we think of a question always having a single answer, and we aim to get to that answer. But we don't want you to think like that. We want you to think about how we can play with numbers, how we can change numbers to spot patterns, and to begin to reason with maths, which is why we call it reasoning. So there are 3 levels of activity for this challenge, and I'll talk you through how I think you could go about approaching this challenge.
So in this challenge, you will have to multiply a 2-digit number by a single-digit number to produce a 2-digit number. But the second digit in your answer must be odd. So that really limits the number, the types of numbers that you can use, and the combinations that you can use to get there. So you can start to think about how you can look at number patterns and the way that numbers work to try and make sure that that is always odd. So really think about your times tables and how that can help you. Now, at the starting point, you will have to start by just choosing some numbers, throwing them into multiplication and seeing what you get. I would always start with easy times tables, so I've started with the 5s. Okay, there's a reason why I've started with 5s as well, and you'll see when you see the answers. So, my first question I'd look at is 13, so I put my 1 in here, 3 here, and then multiply that by 5. Okay, and now it's just a case of my short multiplication. So 5 times 3, 15, try my 1, 5 times 1, 5, add the 1 is 6. Of course it's actually 5 times 1 tens, and then we add an extra 10 onto that. Gives me an answer of 65. So does that satisfy my answer? Well, yes it does, because the second digit is odd. So already I know that I can use multiply by 5 to produce answers here. So can I do that with every single number? So I've tried the next one up. Now notice I've gone systematic here. Rather than choosing another random number, I've gone 1 up. So I've gone 14 times by 5. Let's see if this one works. Okay, straight away, 5 by 4 is 20. Now straight away I can see that that is not odd. So I don't need to do the rest of the sum. I know that that number will not work. So that is not one of the possible solutions. I'll do it just for the sake of it. So 5 by 1 10 gives me 5 tens, add the 2, 7 tens. You might also spot a pattern going on here, which might also mean that I don't have to use the long multiplication on my next answer here, because if I spotted that pattern, I know it's going up 5 every time. And in that case, that works. 75. So you might be able to use that pattern to be able to predict, or, well not predict, but use your mathematical reasoning to tell me which numbers I can multiply by 5 in order to satisfy this equation. Okay? Now you might have spotted that if I multiply an odd number by 5, it works. But what about this one here? 21 times 5. Well, let's try it. So, 1 times 5 gives me 5. Nothing to carry. 5 by 2 tens. I don't know why my mind's gone blank there. Gives me 10, lots of 10 tens. 105. The reason why I've shown you this one is because yes, it ends in an odd number, but does it satisfy the question? No, because it is a 3-digit number answer. So therefore, at a certain limit, the trick of using the odd numbers for 5 times tables won't work. So what you've got to do now is try and work out which numbers will work for all, to work out a combination for how many different ways there are to satisfy this. That's if you're doing the level 3 challenge. And there's a few things here that will get you started, a few thinking points for you. Can this be an even number? So can you multiply by an even number to get to the answer? Is that possible? And what if this number here was the number 1? Give that a go.